Alright, in this video I'm going to show how to align the electro-optic modulator. So in our system we have, a laser beam that comes out of the, the ultra-fast oscillator, goes through some series of mirrors here, bounces around. I'll cover all that stuff in a different video. But at some point it comes to this electro-optic, it comes to a polarizing beam splitter. So in our system it sits here. The stuff that goes, so depending on the polarization of the incoming light, some of that will either be transmitted or reflected at a 45-degree angle on this polarizing beam splitter, depending on the polarization of the incoming light, which we control with a half wave plate just before that optic. So the tricky part is that what comes off as a 45-degree angle from this polarizing beam splitter has to get through our electro-optic modulator. So this is the piece that basically turns on and off the laser at speeds approaching, on the order of tens of megahertz. Now you can see that this thing has a really tiny hole here that the laser beam has to get through, and you can see that it's actually quite long. It's on the order of about 12 inches in our system. So, and in fact, the hole that it actually has to make it through, so there are actually a series of there's actually a series of essentially piezo crystals in there that that basically form a very tight aperture. I believe the spec is something like 2.7 millimeter diameter hole. So, if a typical spot size, is on that order, it's a pretty tight fit. So aligning this part is probably one of the toughest things in the system. So what I'm going to do here is so I've already got it set up so that my laser beam comes in at the right height. So I walked the beam with an aperture to make sure that the laser beam is the right height here. In my system that's 5 inches, but that's really a design thing that you get to choose. So what I'm going to do is I'm going to send that beam, so rather than try and align it through this thing fully hooked up, I've got a special alignment tool that I'm going to use to do this. So what I'm going to do is disassemble this system and actually pull out this optic and put in a special alignment piece that has a really tight hole in it, and I'll show you how to do the alignment. The long and short of it is that I'm going to send a beam through this alignment tool, and the alignment tool doesn't have any electro-optics in it. It's just essentially an aperture in a tube. And what I'll do is I'll pull out so in our system we've got a mirror that sits right at the exit and sends the beam to the time delay stage. What I'm going to do is I'm going to pull out this mirror, and I'm going to replace that with a power meter. And I'm basically going to just measure how much power goes through the aperture, and I'm going to move around. Essentially what I'm going to do is I'm going to move around the combination of this beam splitter and this electro-optic modulator until I have as close to 100% transmission as I can get. Before I start using the aperture tool, like the tube that's got the little hole in it that I'll show you, what I'm going to do is I'm actually just going to make sure that the laser beam that comes out of here goes straight down I'm going to align the laser beam first, and then I'm going to adjust the electro-optic modulator around the laser beam. So I'll show you a little bit more about this stage after I break this video. But basically what I'm going to do is I'm going to make sure that this laser beam is pointed straight down one of the screw holes of the table and at the right height. And then I've got a special stage here. I purchased this from Canoptics. So that stage has enough degrees of freedom that you can align the electro-optic modulator around the laser. So let me break and pull some of this stuff off and show you what it looks like.